All right, advanced geometers, welcome back to another exciting and wonderful day of home learning. All right, got another video for you. I know you guys are stoked. I've been getting a lot of hits online. Okay, I'm really trending right now with my geometry videos. Pretty exciting. So today we're going to talk about similar triangle shortcuts. All right, let's check it out. Remember, when we learned about triangle congruency, there were 5 shortcuts that we used to prove that triangles were congruent. There were side, 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 angle, side, angle, side, angle, 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 side, and HL. Well, there are shortcuts for triangle similarity as well. This means that rather than having to show all 3 pairs of corresponding angles are congruent and all 3 pairs of corresponding sides are proportional, we can simply use one of the following 3 shortcuts to justify that you have similar triangles. The very first is AA, or angle-angle similarity. All right, this is the absolute easiest because all you got to do is show that 2 angles of one triangle are congruent to 2 angles of another. That means the triangles have to be similar and you were done. And you might say, well, why don't you have to show all 3 angles? Well, because in a triangle, all the angles add to 180 degrees. So if 2 angles of this triangle are congruent to 2 angles of this one, the third angles have to be congruent anyway, so it's just a bit redundant. So check it out. In the given, I know angle A is congruent to angle D, but that's only one A. It's only one pair of congruent angles. But you guys, I'm sure, remember we got vertical angles here, and there we go. That is enough to show that these 2 triangles are similar. So now I'll very carefully write my similarity statements. If I said, hey, triangle ABE is similar to triangle blah, and again, you guys bear with my terrible handwriting on this tablet thing, I'm going to very carefully match up the corresponding parts. Now, A was the one marked angle here, and that corresponds with D in this triangle. B was the unmarked angle, that corresponds with C in this triangle. And then E was my vertical angles, the 2 arced angles. So, I set up my similarity statement, and then I give a reason. And the reason these triangles are similar to one another is because of angle-angle similarity. Bam, done. Now, if we were in class, we'd be doing proofs with this, but we're not going to. All we're going to ask you to do is to justify, hey, are they similar or not? And if you have AA, you say yes, you give me a similarity statement and a reason, and we move on. All right, the next is called side, side, side similarity. And this says that if 3 sides of one triangle are proportional to 3 sides of another, then the triangles must be similar. Now, you guys remember, proportional means in the same ratio. All right? Now, here is an important note. When you're testing this, you want to make sure that you match up the big side with the big side, the small side with the small side, and the middle side with the middle side. Because if they're going to be corresponding sides, the biggest side in this triangle would have to correspond with the biggest side in this one, and so forth. So check it out. Here's what I mean. In this triangle, the biggest side is 9. We'll put a little B there for biggest side. Now, you guys, this, by the way, is about 5.33. All right, so over here, the biggest side is 6. Right over here, the middle side would be 8. And over here, the middle side would be the 16/3. And then in this first triangle, the smallest side is 6. And in this triangle, the smallest side is 4. And the reason I want to establish that, you guys, is because when I determine if they're proportional or in the same ratio, I'm going to put the bigs together, the middles together, the smalls together. Let's check it out. All right, the big over here is 9. The big over here is 6. Does that equal the middle over here is 8 and the middle over here is 16/3? And does that equal the small over here is 6 and the small over here is 4? Now, to determine if these are all the same, I'm simply going to divide them in my calculator, or you could do it by hand, whatever you want. But proportional means in the same ratio, so I just want to see when I divide these, do I get the same thing? Well, 9 divided by 6, as you guys know, is 1.5. And if you punch this in your calculator, put a parenthesis around this fraction, all right? But also, you guys, I don't need a calculator for this. That's 8 over 1 divided by 16/3 is the same thing as multiplying by 3/16, multiplying by the reciprocal. Well, that gives me 24/16, which simplifies to 3/2, which is also 1.5. But again, if you just punch it in your calculator, it'll spit out 1.5 as well. And 6 divided by 4 is also 1.5. So you'll see every single pair of sides in this triangle to this one. All right, I got 3 sides of this triangle are proportional to 3 sides of this triangle. Therefore, they are similar. So my similarity statement, just be very careful. If I do A, B, C, I want you to notice that A was between the small and the big. So over here, I'd have to do E first between the small and the big. All right. And next I did B. B was between the small and the middle. And over here, D is between the small and the middle. And finally, C was between big and middle. And over here, F is between big and middle. So you just got to take your time and be careful with that similarity statement. And then by, these triangles are similar because of side, side, side similarity. Booyah. There we go. And the last shortcut is side angle side. All right. Now in this case, we need 2 sides of one triangle proportional to 2 sides of another, and the included angle. Remember, included means between those sides we referenced are congruent. So check it out. I also had to be really careful, just like in that previous problem. I'm going to do big over big and small over small. All right, so check it out. In this triangle, first of all, I noticed the vertical angles. Go ahead and mark that. So I can guess, hey, it's probably going to be a side angle side situation based on how it looks. Now, this is the bigger of the given sides. This is the smaller. This is the bigger of the given sides. This is the smaller. So I already have the A. Bam. I got a congruent angle. Now let's just check and see if the sides are in the same ratio. Well, the big is 5 over 10. And the small is 4 over 8. And you guys obviously know, if you punch out in your calculator, you get 0.5, you get 0.5, and bam. So I've satisfied everything to this theorem. I know that you've got the angles congruent, and those 2 angles are included between proportional sides. 5 to 10, 4 to 8 are both a half. So I know that triangle AED is similar to triangle. Now be very careful. A was between big and blank. So I'm going to start with C between big and blank. Then I did E. E was the vertical angle, so of course I'll do E here. And then finally that leaves me B. And by side angle side similarity. Again, I know my handwriting is terrible on this thing. Great. That's it. So let's just look at a couple quick examples. All right. So determine if they're similar. If they are, finish the similarity statement and give a reason. So you'll notice in example 1, I have parallel lines. Well, parallel lines, you have congruent alternate interior angles. That angle is congruent to that angle. Now, that's 1A. I could do the other pair of alternate interior angles. You have this little Z right here. Or I could have done the vertical angles. It doesn't matter. Either way, I'm going to get AA. So for sure these triangles are similar. And now I'm just going to match up my similarity statement. And of course, this is going to be by angle-angle similarity. All right, so let's see. G was 2 marks, so I'm going to put D first. And then C was 1 mark. I'm going to put F next. And then E was that vertical angle. So there we go. Those triangles are similar, and there's your reason. Now this next one. It looks to me like we're going to do side angle side because I have that vertical angle thing again. All right. Now in this triangle, this is the big one. This is the small one. Big one, small one. So now I just got to see if those sides are really proportional. All right. If I do small over small, I get 2/3. And I want to know if that equals big over big, which is 4/5. All right. So again, the small sides are 2 and 3. The big sides are 4 and 5, and are those the same ratio? Well, you guys know that 2/3 is approximately 0.67, and we know that 4/5 is 0.8. Those are not equal to one another. Therefore, those triangles are not similar. So, bam, bam, nothing I could do there. It looked like it might be side angle side, but at the end of the day, it wasn't. All right. All right. Now, sometimes the triangles are going to be attached or they'll be overlapping, like in this case. And if that's the case, you guys, it may be helpful to draw them separately. So this is E, F, G. This is 6, 3, 6.75. All right, then I have my bigger triangle here. This is E, H, I. This is 4. This is 9. And this entire length, EH, you can see is 8. 6 plus 2 is 8. All right, so I'm going to do the small side over the small side. It looks like it's going to be side, side, side. We've got to test it. All right, the small over here is 3. The small over here is 4. Does that equal? The middle side over here is 6, and the middle side over here is 8. And does that equal the big side over here is 6.75 over the big side over here is 9. All right, now I know 3/4 is 0.75. I know that 6/8 is 0.75. But let's check 6.75 divided by 9. When I punch that in my calculator, I get 0.75. So all 3 pairs of sides are proportional, so the triangles are similar. And I'm just going to be very careful. I said GFE. Now G was between big and middle. So over here I'm going to start with E, which is between big and middle. Next I said F. F was between small and big. And over here I is between small and big. And then finally I ended with E. E was between little and middle. And over here H is between middle and little. And the reason is side, side, side similarity. Now in this case, you guys will know that that's a right angle. All right? So you could tell it might be side, angle, side. But how about I take this triangle and I draw it so that it looks like this guy with the small side, which for this triangle would be 2. And the longer side is 12.5 here, but the longer side in this triangle is 5. All right? And if I relabel this one, this would be A, B, and then the right angle there is D. So just kind of moved this triangle here, reorientated it, so that they match up. Now let's just see if they have the same ratios. So is 5 over 2 the same thing as 12.5 over 5? Well, 5/2 is 2.5, and 12.5 divided by 5 is also 2.5. So yes, those triangles are similar. And ABD is similar to BCD by side, angle, side similarity. So when the triangles are connected, sometimes it helps to draw them separately. And in this case, I drew them in the same orientation, with the small side being vertical and the big side being horizontal, and the angles in the same place. And then the last example, you guys, is using similarity to solve for a side length. So first, are they similar? Now I know these two triangles are similar because 1, ABE and ACD, they have a common angle A by the reflexive property. And 2, I know that ABE, this angle, is congruent to angle ACD because they're corresponding angles and we had parallel lines. So if I draw these triangles separately, just like we did in the other lesson, this is B, this is A, this is E. All right, I'm going to try to draw the big one here. Again, I know this is terrible drawing. This is A, that's C, that's D. I know that angle A is congruent to angle A by the reflexive property, and I knew that angle ABE was congruent to angle ACD because corresponding angles are congruent when you have parallel lines. Now I'm going to label the triangle. This is 4, this is 6. I got that from here and here. Now notice AC is this entire length, which is 10, and CD is X. So are they similar? Yes, they are similar because of angle-angle similarity. Angle, angle. Next, find the similarity ratio. Well, if you look at these triangles, this and this correspond. So the similarity ratio is 4 over 10, which is 2/5. And then I'll use that to solve for X. 2 over 5 is equal to 6 over X. And I'll cross multiply and I'll get 2X is equal to 30. So X is equal to 15. There you go, you guys. That is the triangle similarity shortcuts and how you apply them. All right. Be sure you read section 11.2 in your textbook if you need some further clarification. All right. You guys have a great day, and let me know if you need any help at all.